In this section, we will be talking about adding like terms. So we need to understand a couple of definitions first. We need to understand the word coefficient and the word variable. A coefficient is a number that's multiplied times a variable. In this example, 4 and 2 are both coefficients. A variable is a letter that could represent any number. If you have the same variable, then they represent the same number. You just don't know what the number is. So in this case, x and x represent some number and the same number. If I had 4x plus 2y, x and y would represent two different numbers that I don't know. And 4 and 2 would still be considered coefficients. So what 4x actually means is that I have 4 of some number that I don't know. In other words, I have one of that number, another of that number, another of that number, and another of that number all added together. And of course, a shortcut to addition is multiplication. So instead of saying we have that number plus that number plus that number plus that number 4 times, we just say 4 times that number. And we represent this idea with 4x instead of 1x plus 1x plus 1x plus 1x. The same idea holds true for 2x. 2x means that I have 2 of some number. So I have that number plus that number again, but instead of saying 1x plus 1x, I just go ahead and say 2x as a shortcut. So therefore we can conclude that if we're adding 4x plus 2x, that's the same as adding 1x 4 times and then 1x 2 more times, that altogether, how many x's would you imagine that we have? If you were thinking 6 x's, you would be correct. And the general rule here is that if you have the same variable, go ahead and add the coefficients and keep the variable, which is what we just did. We added the 4 plus the 2, and that gave us 6. And we just keep the variable x. So 4x's plus 2x's gives us 6x's, or 4 plus some number plus 2 times that same number give us 6 of that number altogether. So let's do some examples. Notice that here I'm allowing positive 1 to be represented by a yellow square. We'll call that a chip. And then I'm allowing negative 1 to be represented by a red chip, and I'm allowing 1x to be represented by blue and negative 1x to be represented by purple. So think about how you would represent 1. You thought a yellow square, you're right. What about negative 1? That would be a negative red square. 1x, a blue rectangle. Negative 1x, a purple rectangle. So how would you represent just x? Well, x is the same thing as 1x. There's an understood 1 whenever you see x by itself. That means 1x is the same thing. So what do you think we would do to represent negative x? What would we use in these pictures? If you're thinking negative 1x, then you are correct. Negative 1x is the same thing as negative x. That's just one negative x, or one negative of some number. Really, it means the opposite of some number. That's what negative x means, the opposite of some number. And negative 1 times x makes it the opposite. So how would you represent 3? What do you think we should drag down? How about 3 1s? How would you represent negative 2? Maybe drag down 2 negative 1s? And these are called constants, by the way. When you're working with numbers that are not being multiplied times variables, they're just regular old numbers, these are called constants. So 3 is a constant and negative 2 is a constant. How would we represent 4x? What do you think? Maybe drag down 4 1x's? Good. So that's 4x. And then how do you think we'd represent negative 5x? We drag down 5 negative 1 x's. So that's negative 5x altogether. So now what would we do to represent 1x plus 1x plus 1 plus 1 plus 1? So what do you think? Drag down a 1x, another 1x, and 3 positive 1s. Now here's the next question I have for you. What does that equal? So this is a positive 1x plus a positive 1x. How many x's do we have there? What would you get when you add all that together? 2 x's? And then we're going to add to that these 3 positive 1s. So what does that equal? 3. So this is 2x plus 3. This is called an expression. And we can't add our x's and our 3 together. So that's the final answer. Because x's, we don't know what they are, but we know we have 2 of them. 3 is just the number 3. So since we don't know what the x is, we can't add the 2x to the 3. So how would we represent in the next problem negative 1x plus negative 1x plus negative 1x? Are you thinking that we would drag down 3 negative 1s, 1x's? That's what I'm thinking. And then how would we show the 2 1s? Just drag down 2 1s? So now here's your question. What does this equal when you put it all together? Like in our previous problem where we ended up with 2x plus 3. So we have 3 negative 1x's. So what's negative 1 plus negative 1 plus negative 1? That's negative 3, right? So we have negative 3 x's, or the opposite of 3 times x, or the opposite of 3 of x. Plus we have 2 1s, and we know that 2 1s is just 2. Again, we cannot add negative 3x and 2 together because we have negative 3 of some number, but we don't know what that number is. So until we know what that number is, there's no way to add negative 3x plus 2. We just have to leave that as our final answer. So now let's look at the next problem. We have 3 x's. So let's represent that by dragging down 1x 3 times, and then we have 3 1s. So what do you think that would equal? If you think it equals 3x plus 3, you are correct. The next one, we have 2 negative x's, so let's bring down 2 negative x's. And then we have 2 1s. And so what would that equal altogether? You thinking negative 2 x's plus 2? That would be correct. Okay, so let's keep going here. Let's bring down 2 x's for this problem. And then we have a positive 1. And then look, we have a negative 1x. Another negative x. Remember, x is the same as 1x. Negative x is the same as negative 1x. And then we also have a negative 1 to bring down. So this is getting a little interesting. What happens anytime you put a positive and a negative together that are the same? They cancel, right? So I'm going to drag this negative 1x and put it with this 1x to show that they cancel. And I'm going to drag this negative 1 and put it with this 1 to show that they cancel. Maybe I'll just cross them out to make sure I remember that they have canceled each other. So what are we left with? We're left with 1x, right? Which is just x. So this equals x. Let's look up in the problem and see if this makes sense just visually looking at it. So this x is going to cancel with that negative x, because when you add opposites, they equal 0. This 1 is going to cancel with that negative 1, and all we're left with is x. So let's look at the next problem. Let's see if we can do it without dragging anything down. Well, let's see if there's anything we can cancel to start with. We have a negative x and a negative x, and oh, here's an x. So what can we cancel? We can cancel one negative x and one x, right? Then we have a 1, a negative 1, and a 1. So we can cancel a negative 1 and a 1. So we are left with negative x and a 1. So how would we write that then? How about negative x plus 1. And if it helps you, you're welcome to write it as negative 1x plus 1. It doesn't matter to me. So now let's move on and do some more challenging problems. So let's say we have a problem like this, 2x plus 4x. Let's apply what we've learned. We would go through and we would add the coefficients and keep the x. So what would that equal? 6x. We actually did this problem as our very first example. Now, in our next example, we have different variables. So what we're going to do is add the ones together that have the same variable. That's really important because if we don't know what x is, then we can only add x's together. And if we don't know what y is, then we can only add y's together. So 3x plus 2x is what? That's 5x's altogether, right? Plus 2y plus 4y is 6y. 6y's altogether. Let's do this last problem here. We need to change all subtraction to addition to start with. So we're going to get negative 4x plus 3y plus 2x plus negative 6y as our first step. So now that we've changed all subtraction to addition, we're going to want to add our like terms together. So sometimes it's helpful to underline in the same color our like terms. So we have our x's that will be added together, and we have our y's that will be added together. So negative 4 plus 2 equals negative 2. So we have negative 2x's plus 3 plus negative 6 is negative 3. So we have negative 3y.